What's going on, everyone? Welcome back. Patrick here, and moving on to the next video, we have more limits to solve. These are infinite limits as well. So we got the limit as x approaches pi of cosecant squared x over x, and then the limit as x approaches pi of cosecant x over x. So notice very similar functions. This one is cosecant squared x. This one is just cosecant x. And for this specific video, I'm actually going to do the same method that I did in the previous video where we did the change of variables. So there's going to be a little bit more work, a little bit more algebra, but you can also solve these limits with a table if you want. So you would take pi, which is the decimal form 3.14, and then a bunch of other decimals, and then you would pick numbers really close from both the left and the right side. Notice that these aren't one-sided limits. We're approaching that pi in general, not from the positive side, not from the negative side. So if we're looking for the general limit, we have to approach it from both sides. So we would actually have to find the limit as x approaches pi from the positive side and from the negative side. And then if from both sides the y values are approaching the same thing, then that limit is going to exist and it's going to equal that same value. So for now though, let's just keep the limit like this. And what I'm going to do, like in the previous video, is I'm actually going to take this function and I'm going to split it up a bit. So I'm going to take the 1 over x out, and then the cosecant squared x, I'll separate it like that. Now, cosecant x is the reciprocal of sine. So that means that this here we can actually rewrite as 1 over sine squared x. So cosecant x is 1 over sine x, so cosecant squared x is 1 over sine squared x. And then this sine squared x we can actually rewrite as sine x squared. Just because then I feel like it's more obvious that we can't make a direct substitution. So notice if we try to sub in pi for the x values, here it's fine. We'll have 1 over pi, which is a value. But sine of pi is 0, and 0 squared is 0, and then 1 divided by 0 is undefined. So we can't do that. So at pi there's going to be a vertical asymptote. So what we can do here is now we could distribute this limit to both of these functions. So we have the limit as x approaches pi of 1 over x. And then over here, the limit as x approaches pi of 1 over sine x squared. So over here, this value is equal to 1 over pi. But this value we're going to have to do a little bit more work on. And so like before, what I'm going to do is I'm actually going to make a substitution where we'll have u equals sine x. I'm going to let u equal this sine x value here. So sine x, so if this is u and then this is x here, sine x we know looks like this if we draw one period, and then the pi value is over here. So we know when x is pi, this u value is going to be 0. Okay, so as x approaches pi here, what is u going to approach? Well, as we approach this pi value from both sides, notice that the u value is approaching 0. Okay, so we can actually take this limit here. You know what? Let's just continue it here. And we can rewrite it as the limit as u approaches 0 of 1 over u squared. Right? So notice that I took all of the x variables and then I switched them all in terms of u. So now as x approaches pi, that got changed to as u approaches 0. And then 1 over sine x squared got changed to 1 over u squared. And now this is a lot easier, in my opinion, to work with than that. So u squared, if you were to graph it, it basically looks like that. Everything is positive. right? The range, all of the y values are greater than 0. And so notice that as we approach u from both the positive and the negative side, it's going to go towards positive infinity. And we have to approach it from both sides, because remember, they're asking the limit as x approaches pi. So it's not a one-sided limit. So we have to approach pi from both the positive side and from the negative side. So if we take the limit as x approaches pi from the negative side, that's the same as approaching u, as u approaching 0 from the positive side. So as we approach this pi, this x value of pi from the negative side, we're approaching this u value of 0 from the positive side, right? Because all of the u values very close here are going to be positive. And then the limit as x approaches pi from the positive side is the same as the limit as u approaches 0 from the negative side. So as we approach this x value of pi from the positive side, the u values are approaching 0, but they're all negative, right? So we have to find both of these limits. And notice that both of these limits are going towards positive infinity. And so that means that this limit here, this entire limit, is equal to positive infinity. So positive infinity times this times a value is going to be positive infinity. And so that is the answer for that first limit. It's positive infinity, right? So I know this is a little bit more complex than doing a table of values. I just want to show you this method in case your prof wants you to do it, because some courses require this method, this sort of change of variable where you're taking this function, this reciprocal function, and kind of changing it to something more simple that you can work with. But again, you can also make a table of values. So you could take 3.14, approach 3.14 from the left side, so like 3.13, and then get even closer to 3.14. And then we approach 3.14 from the right side. So you could pick like 3.15 and then get even closer and closer. And then you'll see that both of those tables, the y values of this function are going to go towards positive infinity. So either way works. Now, what about this limit over here? Well, this limit, the steps are pretty much going to be the same, except this is going to be just cosecant x, so it's going to be 1 over sine x, right? So this is going to be 1 over sine x, right? So let's work from there. Everything else is going to be the same. So I'm going to make that same substitution. Let's go through this process one more time, where we have u equals sine x. And so if we graph it, again, this is u, this is x, and then that's pi right there. So notice this limit, we have to do both the limit as x approaches pi from the negative side of 1 over sine x, and then we also have to do the limit as x approaches pi from the positive side of 1 over sine x. And if we do this substitution here, where u is equal to sine x, notice that this is going to end up being 1 over u. And notice the limit as x approaches pi from the negative side, as we mentioned in this example, that's the same as the limit where u approaches 0 from the positive side. Okay, so as we approach this x value of pi from the negative side, right, if we're looking at the x-axis, we're approaching it from the negative side. The u values, which is the y-axis in this case, are approaching 0, this value here, but from the positive side, from up there. We're approaching 0 where u is positive, right? That's why that happens, that change of sign. And then as we approach this pi value from the positive side, So from this side, if we're looking at the x-axis from this side, we're approaching this u value of 0 from the negative side, right? All those u values that are close to 0, but from this side on the function are negative. So this we would change to the limit as u approaches 0 from the negative side of 1 over u. And then 1 over u, it's different than 1 over u squared. It looks like this. Right? With 1 over u squared, basically this turns into a positive. That's why we had that shape before. But 1 over u, it's like this. This part here is negative. So notice the limit as we approach this u value of 0. Notice that in this case now, the u variable is the x-axis. So here was the y-axis. But when we're looking at this function, 1 over u, it's the independent variable. It's the x-axis. So as we approach this u value of 0 from the positive side, from this side, notice that all of the y values are approaching positive infinity. And as we approach it from the negative side, here, all the u values are going towards negative infinity. And so notice that because we're approaching two different y values, this limit actually does not exist. Because if we take this, we have to approach, since we're approaching pi, we have to approach it from both the positive and the negative side. So if we put a positive here and then a positive here, this is going to be 1 over pi. And then this here is the same as this, and we know it's going towards negative infinity. So this times that is going to be negative infinity. So that's the limit of this. As x approaches pi from the positive side, it's going to equal negative infinity. And then as we approach it from the negative side, this is still going to stay 1 over pi. And then this here is going to end up being positive infinity, which would make this positive infinity. And so it's approaching two different values, and so this limit does not exist. Right? So just wanted to show you two functions that are very similar, but the fact that this one has this squared here makes the limit exist, while this one, since it doesn't have a squared, this limit does not exist. And again, you can do this with a table of values if you want. And then those y values should approach the two different infinities from both sides, and you would see that it does not exist. So again, just want to show change of variable method again in case your prof wants to see, but a table of values works with these limits as well.